Okay, good morning to all of you. And today we'll try to complete the portion of ITC subject. Then we'll give a little introduction to the operating system. So let me continue what we have discussed in the previous class. We have discussed about Viterbi algorithm. Numerically, we didn't take any example. But now we will discuss with a numerical example. Hope all of you know how to draw the trolley diagram. Now, considering a trolley, I am taking a G1 equal to 111, G2 equal to 101, and rate half, encoder input was 1110. I got some output. That output I will take as an input. I will use a Viterbi decoder for decoding it. So let us consider. Now, I have received this 1101. 10 and 01. This is the receipt. I'll write down whatever I have received and then I'll compare the received information bits. These two paths I have to consider. Please concentrate here. Try to understand. Hardly 5 minutes or 10 minutes is enough. Now let us consider received is a 11011001. Please observe carefully the screen. I received these 11011001 and these are states and these are output which we have already discussed twice. Now consider this point. From this point I have two paths. Observe carefully. So these are the two paths I am having now. I have to find out the Hamming distance between the output written on these two paths and the received bits whatever I have. So try to see here. Now received is 11. Observe carefully. Received is 11 and output is 00. Hence what I have, Hamming distance is equal to 2. So 11 I have. Hamming distance between the 11 and 00 I have a 2. And Hamming distance between these two 11 and 11 Hamming distance will become a 0. And then I'll continue with the second one. Similarly, the second I have two paths. Observe carefully. From this point I have two paths. So for these two paths, now I have to find out the Hamming distance. Now I have a 01 is received, 00 is output. In between these two Hamming distance is 1 plus 2. Previous Hamming distance is 2. Total it will become 3. This 3 I have to write. Now can you write how much is here in the chart box? Try. The Hamming distance between these two I have to find out. Add previous. How much it will become for this? You can type in the chat box. A total Hamming distance will become equal to. Find out the Hamming distance between received and this output plus previous. So total will become how much here? 3. I think Devidas Naik has told. Channavi, Rohan, Jyoti, Devraj, Praveen, all are typing. So next is I have to consider these two Hamming distance plus 2. The total will become 3. Next I have to consider these two paths. From this point I have two paths. So considering these two paths, again same procedure I have to follow. Hamming distance between the received is 01 and output is 10. Hamming distance will become 2. Previous I have to add. It will become total equal to 0 plus 2. It will become 2. The last one in this column I have again Hamming distance between 01 and 01. It will become 0. Previous 0 I have to add. Total it will become equal to 0. Now, this is very important. For this point, when I want to find out a Hamming distance or a error metric, so I have two paths. What are those? From this, 2 points are joining. See here. Observe carefully. So, considering these two paths, I have to find out a Hamming distance or accumulated error metric. So, how to find out? So, again, follow the same procedure. Now, Hamming distance between these two. This is the output. This is the received. Hamming distance is 1 plus previous is 3. total it will become equal to 4. So simply I am writing 4. Hamming distance between these two plus 3 will become 4. Now second I have to calculate. Previous is 2. Hamming distance between the 1 1 and 1 0. The hamming distance between these two is 1 plus previous 2. Total it will become 3. So 4 comma 3 I have. But what I have to do? I have to keep a minimum. 4 comma 3 I am having. Whichever is minimum, that I have to keep here 3. Similarly, I have to find out for this. Now it is a 1 0, 1 1. Hamming distance you calculate. Previous hamming distance you add. You will get a 1. Another entry is 0 0 1 0. You compare. Previous 2 you add. And something comma something you will get. Whichever is minimum, that you have to keep it. For example, 1 0 and 1 1 hamming distance is 1. Previous is 3. Total it will become 4. One more entry. Hamming distance between the 1 0 and 0 0 is a 1 plus previous 3. So it will become equal to 4 comma 3. Minimum will be 3. So like that you have to continue. And then once if you complete all these things, then what I have to do, whichever is minimum, I have to start from the first point. For example, here I will start from here. Here I have a 2, here I have a 0. Least path I have to consider. So I will go through this. Again from here I have 2 paths. One is 2, another is 0. Which one I have to choose? Minimum. So I will choose this path. Again from here I have 2 options. I can go either this way or this way. Which is minimum? So this is minimum, I will come here. After this, again I have a 2 path. One is this, another is this. Which is minimum? This is minimum. 0 weight. So hence, the Viterbi decoder detects this as a 1, 1, 1, 0. How? Solid lines are 1, dotted lines are 0. So this is the way how a Viterbi decoder works. So let me take another example. Now, with no errors, the same thing just now I told. Let us take some error. That time what will happen? So take a 1-bit error. What is the error, sir? Now this one I have highlighted. It was 0, I have made it as a 1. How the Viterbi decoder will detect this as a 1110? Let us see. Observe carefully. This is very important. Hardly 3 minutes it will take. See here. Now this is a 2, this is 0. Why? All of us know 0 0 1 1. Hamming distance is 2. 1 1 1 1 it is 0. Like that, all of you know how to find out. Once if I keep all these calculations after this, why I am getting 1 here? So all of you know this is a 1 1, this is a 1 0, hamming distance is 1, previous 0 plus 1 will become 1. So these are the entries what I get. Now how to detect? Again follow from this procedure. See here, hey, this is very important, observe carefully. From here I have 2 paths. This is a 2, this is a 0. I will follow this path and I will reach here. Again from here I have 2 paths. This is also 1. This is also 1. Which one I have to take? No book will specify this. Please try to understand. Alternate what I have to do? Compare the next column, which is least. So 2, 2, 2, 1 is there. So this is a least. Now this is a least. So this is a 1 least. This is a 1 least. So to reach from this minimum to this point, can I go through this point or this point? You can understand easily. So therefore, from this point, should I go to 0, 1? Should I go to 1, 1 to reach this? Because this is a minimum in this column. I repeat. So this is a minimum. I have to reach here. From where? This is a minimum. Here 2 are equal. Which one to take? As I know, I have to reach here from here. So you people can easily say whether I should go to 0, 1 or 1, 1. Can you type answer in the chat box? I am here now, minimum. Next minimum is here. These 2 are equal. Should I go to the 0, 1 or 1, 1? Yeah, 1, 1. Why I should go to the 1, 1? If I go to the 1, 1, next I will reach here. Otherwise, if I go here, sir, what is the problem? There is no connection from this point to this point. I cannot come. Hence, I have to decide this I should not take. I should take this by observing the next column. So now, what I have to do? So I will take this. After this, which is a minimum among these 4? This is a minimum. Again, from this I have 2 points. Which is minimum? not 0, I am asking minimum. So this is a minimum. Hence again it will decode like this. So this is also what? 1, 1, 1, 0. Even though 1 bit error is there, I could able to get the data 1110. So this is the way how even though error is there, we can recover from the error. Next, if 2 bits are in error, what is the problem? If 2 bits are error, then problem is, so this will become 0. For example, 1 0 1 0, this is also 0, 0 plus 0, so it will become 0. So path will go wrong automatically. So Viterbi fails to recover from burst error. This is the one sentence which you have to remember. If here and there 1 bits are changing, then it is easy. Otherwise, if it is changing a burst means continuous ones, zeros are changing, continuous bits are changing, then Viterbi decoder cannot recover from that error, cannot recover the data, original data. This is the one line which you have to remember and understand. So this is about a Viterbi decoder. So this will go a different path which is wrong. This is happening because of a burst error. So this is the one point which you have to remember. So a lot of students have worked on this convolution coding and decoding, and these papers are available. Those who want to work, they can just go through these papers done by your seniors or alumni, and these are available in your Google Scholar. You can just go through also. And now many papers are there in the IEEE Explore also. Few students, they have done the paper in IEEE International Conference on this only, using convolutional coding and decoding also. And this almost I concluded this chapter. This just for your information. Just read it, 4-5 slides, I run it, then I will stop this presentation, then I will go to the introduction to the operating system. He has done BTech from IIT, and this person also has done BTech from IIT, but he is working in the Google. All of you know him well, and the similarities is there between these two people. Both are BTech in metallurgical engineering. The same year they have passed, one from IIT Kharagpur and another is from IIT Bombay. I want you people to read these two lines. One works for the company that helps people to search for content on the internet or web. The other gives a company association or to search God within and around us. One developed the Chrome and other developed Govardhana Eco-Village. Just this person has completed engineering from IIT Delhi and later did his post-graduation from IIM. So even if you Google Acharya Prashant, you'll get a lot of information. He's a great speaker. Even he is from Indian Institute of Technology, Delhi. He is graduated, and anyway, now let me conclude, and then we'll go to the. Wish you all the best for your end semester exams. Do well, and if you have any doubts, you can just post in the classroom so that I can take another class and I can clarify your doubts. Thank you, and now I will conclude the class. Then we'll go for the